Hello, so this is A-level physics, and today we are going to discuss Winter 22 paper 1 variant 1. So let's start with question number 1. Question number 1 says that what is needed to accurately represent the physical quantities? So physical quantity consists of a unit and a magnitude, so C is the appropriate answer. Question number 2 says that what could be the current and resistor and the resistance of the wire. So we could evaluate the voltage as 3.6 volts by V equals to IR, and the appropriate answer is D using appropriate prefixes. Question number 3 says that the percentage uncertainty in displacement is 2%, in time is 3%, and what is the percentage uncertainty in G? So the percentage uncertainty in S plus 2 into percentage uncertainty in 2 into 2 would make 2 plus 3 into 2, which would make up 8%, so C is the appropriate answer. Question number 4 says that which quantity is a vector quantity? So A is the appropriate answer. Speed, temperature, and Young modulus are example of scalar quantities. Question number 5 says that a particle accelerates from rest, which shows the variation of the velocity with acceleration of A of the particle. So acceleration remains constant in an equation of motion, so it would not change, it would remain uniform. There are two conditions. The one of the condition is that a particle is moving in a straight line, and the other is that the acceleration is uniform constant. So D is the appropriate answer. Question number 6 says that which graph shows how much distance does it take before the parachute opens. Before the parachute opens at this point, this is the point when the rapid deceleration occurs. So we could count the boxes. So that's 25 plus 25 plus 15 plus 15 plus 15 plus 15 plus 18 plus 11. So that would approximately make up 141 multiplied by one box consumes makes up 4 meters. So 141 into 4 is 570. So B is the appropriate answer. So question number 7 says that what is the definition of linear momentum? So linear momentum is the product of velocity and mass. So C is the appropriate answer. Question number 8 says that a system is given. What immediately after the thread is cut, what would be the upward acceleration of the 0.2 kg mass? So let's first find the force in the spring by when the particle was in equilibrium. So applying up is equals to down would make Fe equals 2 plus 1, 3 newtons, and then when the string is cut, it would make up forward minus backward equals to ma. So forward force, which is the spring force, is 3 minus 2 equals 0.2a. So the acceleration would be 1 by 0.2, which is 0.5 meters per second, which would be so I believe there's some problem with this answer, so I would check it later. So question number 9. One divided by 0.1 1 divided by 2 into 10 would make up 215, so 5 meters per second. So 4.9, that's the appropriate answer. So question number 9 says that a snowflake and the raindrop they have the same mass and speed. The snowflake is greater. The drag force acting on the snowflake is greater than the drag force acting on the raindrop, which statement about the same snowflake and the raindrop is correct? It's part A. It says that the raindrop takes more time than the snowflake to reach terminal velocity. So when the drag force increases, it would make an object reach terminal velocity more quickly. And do remember that considering the drag force is directly proportional to the velocity, and drag force is directly proportional to the surface area. The greater the surface area, greater the drag force, greater the velocity, greater the drag force. Question number 10 says that two trolleys are held together in a horizontal uh, compressed springs when the trolleys are released. So initially they were at rest. The initial total momentum was 0. So when they release the trolley is in contact, the trolley of the mass 2 kg mass to the left has a final speed of 2 meters per second. We have shown over here how much elastic potential energy was stored in the spring. So we can apply conservation of momentum. So the momentum before was 0. So 0 equals m into v1, which is minus 2 plus v into 1. So the speed of the 1 kg trolley was 4 meters per second. So just apply half mv square plus half mv square. We have the velocities, we have the masses. So that would make up 12 joules. So D is the appropriate answer. So question number 11 says that a square board of side length x hangs freely from a nail P as shown. The board has uniform thickness and is made from material of uniform density. A second square board of same side length is made of the same material and has the same thickness as the original board. What is the vertical distance between the positions of the center of gravity of the two boards? What you have to do is first realize that this is a square, so we can apply Pythagoras theorem and find this diagonal's length, which becomes 2x over under root 2. So the half of the diagonal would be x over under root 2. So over here, same thing applies. 2x whole square plus 2x whole square square root would make up square root 8x. So 2 under root 2 8x would be the length of the diagonal. So the half of the diagonal from center to Q would be under root 2x. So the length from one center to the other center would be under root 2x minus x over under root 2. So simplify it would make up x over under root 2. So B is the appropriate answer. Question number 12 says that which forces show that objects are in equilibrium. So considering A, translational equilibrium, half F plus half F makes F, downward force F, so it follows the translational equilibrium. Considering the rotational equilibrium, it also follows because half F into the distance and half F into the distance clockwise makes up equal to anti-clockwise, considering this as the pivot. So A is the appropriate answer. Question number 13 says that what is this vertical force when the distance is 75 and there is a tension T in this rope and a weight of 11 kg hangs from here and the distances are given. So first we need to apply anti-clockwise moment equals the clockwise moment, taking pivot as this point. This Y is our pivot, and applying 110 into 50 equals tension into 75 would make tension into 75 this equals to tension would become 73.3 newtons. So this is 73.3. Now apply the translational equilibrium. So for upward forces equals downward forces, so 74 plus F equals 110, so that would make up 37. So C is the answer. The difference in answers because we are not using G as 9.8. Question number 14 says, that's a repeated question, it has been asked several times before, that composite densities are given, a mixture of glycerine and water and it's have given several data, and it's asking about the volume of the water. So the volume of the mixture is volume of water plus volume of glycerine, mass of water plus mass of glycerine over volume of water plus volume of glycerine. So those masses are not given, so we could find it by density equals to mass over volume. So density into volume, just make it up and write in terms of volume of water and find the unknown, which is VW, volume of water. It makes up 80 centimeter cube. D is the appropriate answer. Question number 15 says that a box initially at the top is being dropped into the surface, and which graph shows of upthrust versus depth. As this box dips into the surface of the water, the formula applies upthrust is directly proportional to the depth, taken from rho GV, which is volume area into height. Area is constant, so it will not change. So height. So once this box would completely dip into this water section, the rho GV section would become constant, so the upthrust force would become constant. So initially, first it would be directly proportional to H. The upthrust would be directly proportional to H. So this is correct, but it does not show the section which shows constant upthrust. So this becomes wrong. This is wrong. C is right because initially it shows directly proportional relation and then it's constant. And D is wrong because it shows that the upthrust is directly proportional to square root of H. So C is the appropriate answer. Question number 16 says that the spring is compressed by a mass. What are the energy changes which are occurring? So D is the appropriate answer. It says that the spring loses gravitational potential energy and gains elastic potential energy. A spring gains elastic potential energy in both cases, when it is stretched or when it is compressed fully. Question number 17 says that a man of 75 kg runs up a staircase consisting of 20 steps. Each step is 20 centimeter high. The man takes a time of 7 seconds to run from the bottom of the staircase to the top. What is the average rate of increase? Average rate of increase is basically power, energy over time, so we can find it by mgh over t. The only thing over here to consider is that the height would be the one step, which is 20 centimeter, multiplied by the number of steps, which is 30, so that would make up 600. So just plug in the values mgh over t, so that would make up 630 watts. C. Question number 18 says that an alpha particle of kinetic energy is given. What is the speed of the alpha particle? We are given with the kinetic energy, just apply half mv square equals 2.2 into 10 raised to the power minus 13, and take the mass of the alpha particle as 4 into unified atomic constant, and find the velocity as 8.1 into 10 raised to the power 6. Question number 19 says that which spring arrangement has the same spring constant as a single spring? So let's see all of them basically. So this makes up, this is in series, so this makes up k by 2, this makes up 2k, this makes up k by 2 plus k by 2, this is k by 2, this is k by 2, so this makes up k. So this is as the original spring k, and this makes up 2k, and this is k, so this would make up 2k squared by 3k, so that would be 2 by 3k. So C is the appropriate answer. Question number 20 says that what is the stretched length of the spring? The unstretched length of the spring is 2 centimeter, and a force of 1.5 Newton is being added, and the tensile energy, the tensile elastic potential energy, strain energy is 0.045. So from E equals to half Fe, we can find the extension, which is 0.06 meters, and which is basically 6 centimeters. So the stretched length of the spring is 6 plus 2 original length, which is 8 centimeter. Question number 21 says that a signal generator, amplifier, and a loudspeakers are used to produce different sound waves in air of room. The relationship between the properties of these waves are investigated. Which relationship is not correct? So amplitude is proportional to the wavelength. According to the formula, E equals half omega square x naught square, energy and frequency are directly proportional. So amplitude is in fact inversely proportional to the wavelength, not directly proportional. It is directly proportional to the frequency. So B says it's inversely proportional to the wavelength, that's correct. That intensity is proportional to the square of the frequency, that's correct. And period is reciprocal of frequency, that's also correct. So A is the appropriate answer because it is not correct. Question number 22 says that speed of a wave is given, a rarefaction and compression. Longitudinal wave pattern is given. What is the approximate frequency? V is equals to f lambda. F is equals to V, which is 340 divided by lambda. Lambda is 0 to other compression area 0.5. So 0.5 minus 0 is 0.5. Lambda is 0.5 would make up 680 hertz. Question number 23 talks regarding the instantaneous motion of particle. It says that a graph is given which is moving from left to right. It says that how would x, the graph of x at point x would be. So we have to see the motion of the particle against the motion of wave. So the instantaneous motion of particle is always against the motion of wave. So this would be the appropriate graphing. So B shows the appropriate graphing. Question number 24 says that a jet aircraft travels at a speed of 0.8 v, that's the source velocity, where v is the speed of the sound. The aircraft directly approaches the stationary observer, so that means that we have to apply FSV over v minus vs. The frequency of the sound emitted by the aircraft is 100, so that's the source frequency. Which frequency does the observer hear? So just apply f0 equals fsv over v minus vs, plug in the values, and the answer becomes 500 hertz. Question number 25 is a recall question. It says that a telescope detects and analyzes some electromagnetic radiations of wavelength 2 centimeter, which is 2 into 10 to the power minus 2 meters. What type of telescope is it? So we have to identify that 10 to the power minus 2 meters wavelength is in which. So considering the recall values, it's the microwave. So A, microwave telescope is the appropriate answer. Question number 26 says that two waves of the same type overlap. When does the principle of superposition apply? The principle of superposition applies to, it always applies. Only when the wave is the same amplitude, it is not necessary. Same frequency, not necessary. Travel in opposite direction, not necessary. So A is the appropriate answer. Question number 27 says that nodes, antinodes, nodes and antinodes, one-ended open pipe is given. It says that which is the graph of the variation of the amplitude with the distance measured from the closed end of the pipe. So considering A, we have a node 0, we have an amplitude maximum, we have a node 0, we have an antinode maximum. So that's A, the appropriate answer. Question number 28 says that a diffraction pattern is given. What happens when the frequency of the wave is half? When the frequency of the wave is half, the lambda increases. When the lambda increases, the wavelength becomes approximately equal to the slit opening. So it would produce a better diffraction, an ideal diffraction like this. So more diffraction is observed. B is the appropriate answer. Question number 29 says that one of the slit intensity of one of the slit is reduced. How does it affect the interference? That's a very popular A-level physics question. So when one of the slit intensity is reduced, in constructive interference, the light becomes less bright, and in destructive interference, it becomes more bright. So D is the appropriate answer. The dark fringe becomes darker, and the dark fringes becomes brighter. Question number 30 says that grating is given. We could find D 1 over G, and we are given with the wavelength, we are given with the order, and we have to find theta. That's a quite straightforward question, and lambda is equal to D sine theta, and theta is 28. C is the appropriate answer. Question number 31 says that a length of wire RS has a cross-sectional area, and the areas are given. The charge Q takes time t to pass through R. There is a constant electric current in the wire. So that means that the current does not change. The current parameter remains same, the other things change. How much charge will pass through at N2? So that means that I is equal to Q over T. So QR over T at end R, and Qs over T by 4 at end S. So we could find Qs. So Qs becomes QR over 4, which is Q by 4. So B is the proper answer. Question number 32 says that a power supply is connected to the component by connecting a wire of total resistance 4.9 ohm. The power supply has an output power of 3.6 watts and terminal potential difference of 12 watts. How much thermal energy is being dissipated in the connecting wires in 1 hour? So first we need to find the current. Current is I equals to V over R. So V over R is 0.3 amperes. Just apply I square RT. Power dissipated is I square RT. T is in R, so converted into 3600 seconds. So this would become 1.6 kilojoules. Question number 33 says that a copper wire is replaced by an aluminum alloy wire of the same length and resistance. Copper has half the resistance of the alloy. What is the ratio of the diameter of the alloy wire and the diameter of the copper wire? So the length and the resistance are the same. The resistivity of copper is resistivity of alloy divided by 2. So we just need to apply the area, which is diameter square over is equals to rho over 2. So that would make up 2, and then take square root because that's area diameter square. So the diameter ratio would become under root 2. A is the proper answer. Question number 34. It says that 3 identical lamps, P, Q, and R, are connected in a battery of negligible internal resistance. The filament lamp wire in lamp Q breaks so that it no longer conducts. So when the Q breaks, it's no longer there. So what would happen is that the effective resistance, would decrease. Effective resistance would increase. So when the effective resistance would increase, the current from the battery would decrease. So when the current from the battery would decrease, R would become dimmer. So now what happens to P? Before, the current in P was coming after dividing into P and Q, like 4 ampere was divided into 2 amperes. Now P would get the whole current. So overall, P would get brighter. So B is the appropriate answer. P becomes brighter and R becomes dimmer. Question number 35 says that what have the same units as EMF, its energy per unit charge. EMF and PD have the same basic formula. Question number 36 says that what is the resistance R? We have converted this diagram into this simplified diagram. VA and VB are marked. Now we are considering 8 in parallel with our 8R over 8 plus R as X, and assuming over here that now it says 0, the voltmeter reading is 0, so we are equaling VA equals VB. So 2 over 2 plus X, applying the potentiometer principle, equals 5 over 5 plus 10, applying the potentiometer principle. So making it solving it up gives us X equals 4. So now replacing X equals to 4 being equal to 8R over 8 plus R, applying the product over sum because they are in parallel. So R makes up 8 ohm, so D is the appropriate answer. Question number 37 says that what changes would cause a positive reading? So in order to make a positive reading, the voltage of X must be greater than the voltage of Y. So voltage of X can be greater than the voltage of Y when the intensity of the light dependent resistor decreases and its resistance increases. When its resistance increases, its voltage across Y would voltage across when the voltage across when this resistance would increase, this resistance voltage would decrease. So when this voltage would decrease, so the voltage of X would become greater than the voltage of Y. So C is the appropriate answer, which says that reduce the intensity of the light incident on the LDR. Question number 38 says that an alpha particle passes through a gold nucleus and is deflected through an angle greater than 90 degrees. Which property of the alpha particle changes as the result of deflection? Because of deflection, the velocity varies. So mass into velocity, momentum changes. Charge is not changed, nucleon number, proton number are not changed. Question number 39 says that a nucleus of uranium-238-92 decays, emitting alpha and beta particles, forming lead-206-82. How many alpha and beta particles are emitted? So just see part A says 8 and 6, placing it up so that equalizes both the mass number and the charge number, so A is the appropriate answer. Question number 40 says that which list of particles contains only fundamental particles? So the correct answer is B. Is D, lepton, quarks, and positron. The rest contains also contains the particles which are not fundamental. So that's it for this video. Do like and subscribe my channel for more videos, and to those who are watching without subscribing, it's a request to please subscribe to my channel and then watch, and do not forget to press the bell icon. Thank you.